What happens when your MCP tool fails, but you don't want the whole program to crash? We'll handle tool execution errors gracefully by checking the result manually instead of letting exceptions bubble up. You'll see how to inspect the error details while keeping your application running smoothly.
Async with client. Result equals await client call tool. Potentially failing tool. Param value. Raise on error equals false. If result is error. Print F tool failed. Result content 0 text. LC. Print F tool succeeded. Result data.
This demonstrates the explicit error handling pattern for remote procedure calls, where failure states are treated as first-class outcomes rather than exceptional cases. The approach distinguishes itself by making error conditions visible in the control flow, allowing developers to handle success and failure paths with equal clarity. This contrasts with traditional exception-based handling, where errors become hidden branches in program execution. The pattern works by encapsulating both successful results and error states within a single result object, creating a unified interface for all outcomes. This design leverages Boolean flags like isError to explicitly root execution, making error handling an intentional part of the business logic rather than an afterthought. The separation between structured data access and error content maintains clean boundaries between happy paths and failure scenarios. This approach matters because it transforms error handling from reactive debugging into proactive design. It's particularly valuable in distributed systems where partial failures are common, and in workflows where recovery paths are as important as primary logic. The trade-off is slightly more verbose success paths, but the benefit is predictable control flow that matches how real-world systems actually behave. Let's break it down line by line.
Async with client.
Context Manager pattern for async client connections. The async with ensures proper resource cleanup when the block exits, preventing connection leaks. This is the standard way to handle async client lifecycles in FastMCP.
Result equals await client call tool.
This invokes the AI callable tool asynchronously. The await suspends execution until the tool returns, enabling non-blocking operations while waiting for the response.
Potentially failing tool.
This specifies the tool name being called through the client. In this case, we're targeting potentially failing tool to demonstrate error handling, showing how the client manages both success and failure cases.
Param value.
This is the tool's input parameters as a dictionary. The key value pairs define the arguments passed to the potentially failing tool, where param maps to the expected parameter name and value provides the concrete input. This pattern mirrors how AI models structure tool calls, ensuring compatibility with FastMCP's execution model.
Raise on error equals false.
This disables automatic exception raising on tool failures. Without it, any error would terminate execution. With raise on error equals false, you handle failures gracefully in the response object, critical for robust error handling in async workflows. This closing parenthesis terminates the client call tool invocation, finalizing the asynchronous RPC call to the FastMCP server. It marks the boundary where execution control returns to the caller, allowing the subsequent if block to handle the response.
If result is error.
This checks the tool's execution status. The isError flag handles failure cases explicitly, enabling controlled error handling instead of raising exceptions. This pattern separates success and failure paths cleanly.
Print F tool failed. Result content 0 text.
This accesses the error message from the tool's response content. When raise on error equals false, failures are returned as structured error objects in result content, where the first item contains the error text. This pattern safely handles tool failures without crashing the application.
Else.
This else branch handles the success case when the tool executes without errors. It processes the successful response data, completing the error handling pattern established by the preceding if result is error check. The explicit success path makes the control flow clear and prevents silent failures.
Printf tool succeeded. Result data.
This outputs the successful tool response by accessing result data. The data attribute contains the structured return value from the tool when execution succeeds, providing direct access to the processed results. Error handling pattern. FastMCP's dual error handling modes let you choose between exception-based flow control and manual result inspection, with raise on error toggling the behavior. The content zero text access pattern assumes the error response follows MCP's standard content structure, which may vary across implementations. Always prefer explicit error handling over silent failures when building robust AI integrations.
The error that speaks is already handled. The error that stays silent